Hey everyone, welcome to Zero Labs. Today is Saturday, January 30th, 2016. I'm Mark Brash, your host, and today we learned how to solder. I have oftentimes received requests to share some of my techniques on how I go about soldering. Now, I'm going to confess, I have done this for many, many years. And quite frankly, a lot of it comes with time, but very basically, I want to share with you my techniques that I use for soldering. So obviously, the first thing that we need to solder is a soldering iron or a soldering station. These come in many forms. This one is a soldering pencil with a base. Inside the base is a transformer that steps the 120 volts down to, I think, 24 volts. And you have your main power switch right here that turns it on and off. This soldering station is sort of hacked together. The soldering pencil stand doesn't really belong on the top of this one. It originally had a tray that attached to the side of it, and the soldering pencil and spring sat in a tray next to it, but I didn't have the tray, so I just sort of screwed it to the top of my soldering station, and my wet sponge straddles the spring like that, and I just use it like that. So it's nice and compact. One of the most important parts of the soldering process, however, is keeping the tip clean, and that's what this sponge is for. Right now, of course, this sponge is very dry, and what we need to do is soak it and make it wet. This is one of those synthetic sponges, and they get very hard and they shrink up when they're dry, but they last a long time. I've had this, I think, since I've had the soldering station, and it's still, I mean, it looks like crap right now, but wait till you see it when I soak it with water. So here's a little plastic tray that I made from a blister pack from some electronic component that I bought, and it just so happens that my sponge sits in here nice and neat like that. All I'm going to do is take a little bit of water, pour the water on top. I know about how much water this thing will hold, right? And then I'll just take my fingers and push it down until it swells up and soaks up all of the water that was in the tray. Set it around the base of my soldering station, and now I can just do that when I want to wipe it off and keep the tip clean. So you'll see on this side of my soldering stand I have a couple of holes drilled in it like this, and I have some spare tips. Each tip is a little bit different. This tip right here is what's called a fat screwdriver tip, right? And it is used for not very precise work, but it is very good for transferring a lot of heat to a big piece of material to cause the solder to melt. This tip right here is very long and skinny, comes to a rather sharp point, and is good for reaching into tight places. If you look at the back of the tip, you see it's stamped with a number 7. These come stamped with either a number 6, a number 7, or a number 8. And what that stands for is hundreds of degrees. So when I insert this tip into this soldering station wand, it will regulate the temperature at 700 degrees using a magnet that pulls to the back side of the tip and is regulated by what's called the Curie Effect. As the tip heats up to a specific temperature, the magnetic releases, and the switch is inside the handle of the wand back here. So you hear it go click click every now and then, and it's regulating the temperature based on the widget of metal that's stamped in the back of each of these tips. Kind of cool. This tip right here is short and stubby, but it comes to a very fine point. Now you'll see that it's not very shiny, and that's because there's some slag that has built up on the solder prior to it cooling the last time that I used it. We're going to correct that using the wet sponge. And while we're waiting for this to warm up, I'll point out that soldering pencils like this, or soldering equipment like this, comes in all shapes and sizes. This is a temperature regulated soldering station. There are the simple unregulated type like this, and there are the soldering guns for heavy duty work like this. I prefer something temperature regulated like this because it's much better for electronics work. So I hear it clicking, and I've got a little piece of solder right here. I just sort of spool it up into little bunches like this because it makes it easy to handle when I'm doing small work. All right, and first thing I'm going to do is wipe the tip off, and you can see it's sort of shiny, but it immediately starts to tarnish. So I wipe the tip off, and then I immediately coat it with solder. And then wipe it off again, and it's nice and shiny. This is what you want when you're working with your PC board. First thing I'm going to do is strip off a little insulation from this piece of copper wire, and we're going to pretend that this is the lead of an electronic component that we're going to insert the lead through the printed circuit board. And we'll pretend that that's our component. I'm going to clean off my tip and immediately apply the solder. I'm going to apply just a tiny bit of solder in front of the connection so that I can transfer some heat. You notice there's a little bead of solder on the tip of my iron right now. That's going to help me transfer the heat to the copper foil and to the wire so that I can get that heat to flow the solder that I want to apply. Like that. Now all I have to do is trim the wire. And the wire is properly soldered to that foil trace. Now, one of the things that you need to remember about solder, when it's really hot and it's melted, it behaves an awful lot like water. It is a liquid. And as a liquid, it has surface tension. And because it has surface tension, it will wick up a porous material. A porous material like this is a product called solder wick. What this is a very fine copper braid impregnated with rosin flux to help the solder flow. If you want to remove solder from a connection, all you do is simply place a clean section of the solder wick on top of the solder that you want to remove and apply heat behind it, and it will pull the solder and wick it like a paper towel does water away from the connection. So now you can see we have a little puddle of rosin around the connection because that's what the solder wick left behind. But you'll also see that I have removed virtually all of the solder. There's just a tiny little bit at the edge holding that wire in place, and if I just move the wire, see my solder, my hole is empty, and I have my wire that was easily removable from the opening. The surface tension of liquid solder that allows it to wick up a material like solder wick, the same way water does in a paper towel, is an important property because it also allows you to do some fun things like this. All right, here is a prototype of my constant current pulse width modulator board that's on what's called a proto board with 0.1 inch spaced holes. And I use the surface tension to my advantage when I'm making a board like this to form droplets around the connection points when I'm soldering them together to make my prototype printed circuit boards. So I'll take a printed circuit board design and I'll transpose it directly to a proto board like this. And as I'm applying solder, here's a perfect example right here, okay? I have 3 wires coming together, and I've applied enough solder with just enough heat to form a droplet that joins those 3 wires together. And you can actually make some fairly complex printed circuit boards this way. Okay, let's try another exercise. Let's do something a little more simple. I'm going to take 2 wires, strip the wires, strip the insulation off. I'm just going to twist them together to form a spiral. And I'm going to show you how we flow solder into a connection like that. Now, I confess, I've become very good at using my left hand as a vise with my middle finger and my ring finger, like that, to hold my piece, and my thumb and index finger to move solder into position. For those of you who might not be quite as coordinated as this, there is vices that have little alligator clips. They're very easy to make. You can even 3D print them. All right, but let me show you just how we go about soldering. All right, hopefully the camera will stay focused. All right, notice I apply the heat behind the connection. I start to flow some solder into the connection, and then I apply my solder onto the connection. There is your soldered connection. And of course, like so many things, practice makes perfect. I hope you all enjoyed this little tutorial. Hope you'll tune in for more. Thank you all for watching. As always, please rate, share, comment, and subscribe to my videos. And peace, everyone. And I'm going to apply my solder in front of the joint. And that was terrible. It was terrible because I don't have my magnifiers on and I can't see very well. Ugh. Until I can get it to flow onto the board, and it's not flowing at all. Why is it not flowing at all? Yeah, I just melted a spot in my anti-static mat. Whoops. Okay, there's a blooper. You always want to keep the solder joint still until it is completely solidified, and once it's completely, oh damn, that's hot.